Welcome to today's video. Today we're going to be focusing on factors of difference of squares. And we're going to show that mastery by scoring at least an 80% on an exit ticket. Hopefully you have the note sheet in front of you. If you don't, take out a blank sheet of paper and when you come to class tomorrow we can get you a fresh one. Now, for difference of squares, the big thing to keep in mind, we have a couple of things we have to ask ourselves before we get started. If we can answer yes to all of these, well then our life is going to be really easy. So first of all, are there only two terms? And these two terms, we want it to be the ax squared and our c term. So are there two terms? Can we factor out that GCF? We're still focusing on that if you can factor it out right from the beginning. Once we factor it out, is the first term a perfect square and is the last term a perfect square? If we can say yes to both of those, the last part of the problem is there a subtraction in the problem? And that's key because if there is an addition, we can't do this. It has to be a subtraction. Now, if we can say yes to all of those, what we're going to do is we're going to take the square root of the first term and we're going to take the square root of the second term. When we take the square root, it's going to become a plus b and a minus b, where a and b are our square roots. So whatever we take the square of, it's going to become a plus b and then a minus b. Now, the nice thing is, and we've talked about this in class, it can also be a minus b and then a plus b. Order does not matter as long as the numbers that are supposed to be negative are negative and those that are positive stay positive. Now, if we look at the first one, we have x squared and we have minus 81. So the first question, are there two terms, ax squared and c? Yes. Second, can we factor out a GCF? Well, no. X squared is a coefficient of 1, and then 81 doesn't have an x. So now, is the first term a perfect square, and is the last term a perfect square? Well, they both are. So now, is there subtraction? Yes. So now, we're going to take my a squared, which is equal to x squared, and I have b squared. I'm going to call this c squared, since we said it's the a term and the c term, and I have 81. Well, now I'm going to take the square root of both of them. The square root of x squared is just x, and the square root of 81 is 9. So now my final answer becomes x minus 9, x plus 9. Or I can write it x plus 9, x minus 9. Either answer choice is acceptable, but the biggest thing, we need to make sure we're taking the square root of both parts. If we look at example 3, in this case, we're going to start, are there two terms? Yes. Is there a GCF? In this case, there is a GCF of 2, so I'm actually going to bring out the 2. That leaves me with 36p squared minus 25. Now, I want you guys still in the same habits from class. When you have that GCF, draw your arrow and put your GCF at the bottom. Do not forget that is now part of your answer. So now, are my terms perfect squares? Well, 36p squared is, and 25 is. So now, is there subtraction? There is, so we're going to take the square root of 36p squared, and we're going to take the square root of 25. When we take the square root of 36p squared, well, the square root of 36 is 6. The square root of p squared is p. The square root of 25 is 5. So now I have my a's and c's. So my answer just becomes 6p minus 5 times 6p plus 5. And again, you can switch the order. You can have 6p plus 5 first. It doesn't matter. If we look at example 2, again, we have two terms. We don't have a GCF in this case, but both of our terms are perfect squares, and they both have subtraction. So now, I'm going to take the square root of 16n squared, and I'm going to take the square root of 25. Well, the square root of 16n squared is 4n, and the square root of 25 is 5. So my final answer becomes 4n minus 5, 4n plus 5. Example 4, we do have two terms. In this case, we also have a GCF. So I'm going to pull out not only a 2, but I'm also going to pull out that y squared. We still want to make sure we're taking out the greatest common factor that we can. Well, that leaves me with y squared, and that leaves me with minus 16. I'm going to draw my arrow, make sure my GCF still comes out in my final answer. Well, now I have perfect squares for both terms, and it is subtraction, so I'm going to take the square root of y squared and the square root of 16. That gives me y and gives me 4, so my final answer becomes y plus 4 and y minus 4. If we look at our last two examples, again, example 5, we do have two terms. Well, we have a GCF, so I'm going to take out an 8m this time, and I'm left with m squared minus 16. I'm going to draw my arrow, bring it down. I have two perfect squares in the first term and the second term, and there's a subtraction. So I'm going to take the square root of m squared and the square root of 16. Gives me m and gives me 4. So my answer becomes m minus 4, m plus 4. And keep in mind that GCF is very important to our problem. We cannot just make it disappear. Our answer is not the same if that 8m is not there. Technically, you're not correct. The last one. Again, I have two terms. I don't have a GCF. We need to make sure the first and the last term are perfect squares. In this case, and this is a commonly missed one, which is why we need to make sure we go over it, 1 is a perfect square. And a lot of people forget about that because, well, any number times 1 is that number. It is, but we need to make sure we're also doing the perfect squares. So I have the square root of m squared and the square root of 1. Square root of m squared is m. The square root of 1 is just 1. So this quadratic factors to m minus 1 and m plus 1. Make sure that even if you have that 1, it makes a difference. You can still factor that quadratic. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.